According to the question number 1, we consider oscillator frequency as 4 megahertz. So we are calculating a delay by considering that. So the very first, I will give a brief idea about the code and the simulation. At very first, we adding processor in here. So it's 16F877A, and also here I have added compiler in here. Configuration bit also added here. This is step common for all programming assembly language. In here, in here I have added 2 memory location, which is stores values. I use general purpose registers in bank 0. It's starting from 20. I have used 2 memory locations, 2 registers to 20 and 21. So registers are in bank 1. Registers are in bank 1, so we use status registers. We use status registers to select banks. In here, make 66-bit location into 0. In here, we make 16-bit location into 0, as well as in here, set 5-bit location. Select band 1. In here, clear the RISC. As well as assign the 4B as an output, or D as output. Bit clear if bit save status 5-bit, select the band 0. In here, I have added the loop. Move LW. In here, hold port will be 1. Move LWF for D. In here, I have called delay and clear for D, as well as called delay and got loop. After that, we need to. After that, in here, I have added the delay. According to the question, by considering my registration number, I need to set delay 2348 millisecond delay. I have added 2348 millisecond delay I have to add. So we have more than 250 millisecond delay. We have more than 250 millisecond delay. So in this loop, in this part, we'll create 250 millisecond delay. So in here, in here, I have added 250 in binary. In binary mode, we have added in binary. So it's in time 1. I have called the register time 1 is for time 1, and in here is also also 250, but in loop wise, it's produced 1 millisecond. By after that, it's going to 250 millisecond delay. Finally, this whole set produced 215 millisecond. So according to the calculation, we need to 250 millisecond delay sets. We need 9 set of 250 millisecond delays. So I have added 9 set of 250 millisecond delay. So there's 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. It will give a 2250 millisecond delay. It's will 2250 millisecond delay is will produce. But we need 2348 millisecond delay. So we need to add more 98 millisecond delay. So after that will produce 2348 millisecond delay. This is our code explanation. So let's go to a simulation model. So first we have to go to properties and check whether oscillator frequencies, clock frequency is 40 megahertz. I have already added here, so I need to add the file also there. That's also added here, so I don't add again. So press OK button, and I have added oscillator also to check our delay is whether correct or wrong. So first of all, run the simulation. So as you can see in here, you can see there has a delay of blinking LEDs. You can see in here. So let's whether check our delay is correct or wrong. So I already use here. So and let's check. So I have in here I 1 square represent 200 millisecond. So we need to calculate. We need to check whether our present delay is correct or wrong. So let's check how many holes is there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That has 11. That has 11. 200 millisecond is car. So 11 mean it will produce 2000 and it will produce 2200 millisecond delay. So there has also half of a square, so that will produce 100 millisecond. So when you add that also, it will produce 200 2000 and 2300 millisecond delay. And also there are a few a little side that also when adding that also it will produce to 2348 millisecond delay. So after that we can conclude that our delay is correct. It's produced our delay is correct because it's produced 2348 millisecond delay. So our model is correct. So thank you for listening.